Hello! In this video we will be solving J4 or S1 of the 2023 CCC, also known as Trianglane. I hope this video helps you guys out, and if you believe that someone else you know can be helped by this, then please let them know. With that said, let's jump straight into it. Alright, the problem description says, Bocce the builder just finished constructing her latest project, a laneway consisting of 2 rows of white equilateral triangular tiles. However, at the last moment, disaster struck. She accidentally spilled black paint on some of the tiles. Now, some of the tiles are wet and the other tiles are dry. Bocce must place warning tape around the perimeters of all wet areas. Can you help her determine how many meters of tape she needs? The first triangular tile will point upwards. Each pair of adjacent tiles, that is, tiles that share a common side, will point in opposite directions. Each tile has a side length of 1 meter. The best questions are the ones where they provide a diagram because it's so much easier to visualize. And this is one of those questions I do. So here we go. Here's a visualization of the description. Essentially, as it said, it starts with one triangle pointing upwards. And then there are C-1 triangles after that point in the opposite directions of the previous triangle. That is to say, each triangle points the opposite way. So the first one points upwards, the second one points downwards, the third one points upwards, the fourth one points downwards, all the way up till C. And it's also important to consider that the bottom row, the second row, is the opposite of, points the opposite direction of whatever the first row does. So if the first triangle in the first row points upwards, then the first triangle in the second row points downwards. And on and on and on. Okay? So the input specification says the first line of input will consist of one positive integer C representing the number of columns. The next 2 lines will each consist of C integers separated by spaces. Each integer represents the color of a tile along the laneway, with 1 indicating that a tile is black or wet, and 0 indicating that a tile is white or dry. The following table shows how the available 15 marks are distributed, and we don't care about the table at all, because we're going to get them all. So here is an example. C equals 5, and here are the values, but let's not really look at that. Let's look at the diagram of it on the next page. So here it is. Here's a visualization of it. As we can see, the correct output is 9 because the perimeter of a triangle is equal to the sum of all its sides. We know that these triangles are equilateral, meaning that all the sides are equal to 1, and that one side of one triangle is equal to 1 meter. That's all to say. If there are 3 sides on one triangle and each side is equal to 1, then we have 3 meters per triangle. And once again, if there's 3 triangles, then we will have 3 times 3 meters, which equals 9 meters. So we will need 9 meters worth of tape. So I suppose we can write that down. It's always a really, really good idea to visualize as much as you can and write these patterns and laws that you can think of. So one wet triangle, and I'm going to represent it being wet by squiggling in it, is equal to 3 meters. We'll add on that. We'll add on these rules later on. So carrying on. Sample input 2, which once again is represented by a diagram, shows that there are in total 1, 2, 3, 4, 5 wet triangles, which means that given the law that we just created, we should have 15 meters of tape needed. However, we see that the correct output is only 11. So why is that? Well, as we can see here, these triangles that are horizontal to each other, are touching. They're sharing a side. And since they are both wet, there is no need to put tape in between them. And also, it's happening for here. These triangles are touching vertically. But once again, since they are both wet and they are sharing a side right there, then there is no need to put tape there either. So what does that actually mean for us? Well, let's get a handy pencil out. As we can see, one wet triangle is once again equal to 3 meters. But what happens if there's a second triangle right beside it? Well, here's one side that we need to cover. Here's a second side. Here's a third side. Here's a fourth side. However, this side does not need to be covered. This line does not need to be covered. So, what that means for us, if we were to do this mathematically, is that if P stands for perimeter, then we should technically have 2 times 3 meters, right? However, we'll be subtracting 1 because the first triangle has one of its sides does not need to be covered. And the second triangle, once again, one of its sides does not need to be covered. So we get 6 meters minus 2, which gives us 4 meters. As we can see, we have 4 sides covered, so that's correct. Let's expand this. It's always a good idea to expand. And once you start thinking of stuff, you want to build on it and build on it. Start with something super simple. And now let's make it 3 triangles instead. Oh God, it's one of these weird diagrams again. Okay, this is wet, and this is wet. What's the perimeter? Well, the perimeter is equal to 3 times, because it's 3 triangles, 3 wet triangles, 3 meters. However, this first triangle right here, one of its sides is touching another wet triangle, and so it doesn't need to be covered. So we can think of this as minus 1. For this triangle in between, in the middle, one of its sides is covered, and another one of its sides is covered, which means it's minus 2. And for this triangle, once again, one of its sides are covered, so it's minus 1, which means we get 9 meters minus 4 meters, which gives us 5 meters. Can you guys see a pattern going on, happening? Here it's subtracted by 2, and here it's subtracted by 4. That's because every single time there's a side being shared, every single time a triangle touches another triangle, we have to subtract by 2. So here there was 2 triangles touching, and so it's minus 2. And here there were 3 triangles touching, so it's minus 2. So it's minus 4, because there are 2 sides that are being shared. Wait, yeah, there are being 2 sides that are being shared. Okay, so we can think of this as each wet triangle is equal to 3 meters, and each shared side is equal to minus 2 meters. Okay. But what about when it comes to them touching vertically? As we mentioned, that's also possible. So let's look at that. If this is wet, and this is wet, what is the perimeter of that? Well, once again, it's 2 times 3 meters. And since the first triangle has one of its sides covered, and the second triangle has one of its sides covered, then the perimeter is once again equal to, it's equal to 4 meters, but once again we see that the relation where a shared side equals minus 2 meters is true. So regardless if it's vertically touching or horizontally touching, it's true. I'm sorry, we subtract by 2. And with that said, we are absolutely ready to start programming this. So let's begin. Let's start by importing our scanner. We'll initialize it. Oh my god. Okay, come on. Next, we'll take in the value C. And once we receive C, we will have C values to receive. We can represent these values, or we can store them in a 2D array, but there's no real point. We'll just have two arrays with one array called row 1 equal to a new int with size C. And we'll create another array called row 2 equal to new int with, once again, size C. And we'll just loop through all the values we receive. So it will go up to A will go up to C, A++, row 1 at index A will be equal to in.next int. And we can just copy paste this for the second value. Ooh. For the second row. Awesome. So now we've stored that. But there's also one more thing. One of the rules we had was if a triangle is wet, then we have to automatically add 3. Let's do that. And once again, remember, a wet triangle is represented by +1. So we can say that if int total P, which stands for total perimeter, is equal to 0, every single time that a value we receive is equal to 1, then that means it's a wet triangle, and so we want to add to total P 3. By the way, if you haven't seen this notation before, that means it's plus equal, which means it means equals to total P plus 3. And the exact same is held true for here, or it's row 2 this time. Right, so what this means now is that in this array, or in this input, we receive sample input 7, we receive C, which equals 7. And we go through every single indice of this row, and we add 3 every single time. One of the values is 1, which means we will have 15 by the time we've looped through all of them. And now it's time to subtract 2 every single time there's a side being shared. We can do this by saying, okay, A will start at 0 once again, and we'll start by doing the horizontally. We'll check if they're touching horizontally. First, we'll go up to C minus 1. And we will be going up to C minus 1 because we'll be checking if this current value, if row 1 at A is equal to 1, but also is row 1 at A plus 1 equal to 1? What we're checking is this triangle wet? Okay. Is the next triangle wet? Yes? Okay, if they're both wet, then we have to subtract 2 because they're sharing a side. So we'll go total P minus equals 2. And the exact same is held for the second row. So we'll just copy paste this right there. Boom and boom. And now it is time for the vertical side, sides that are touching. So we will start at A equals 0. A lot of A equals 0s. A equals 0, A will go up to C, A plus plus. And we'll be checking if row 1 at index A is equal to 1, if row 2 at index A is also 1. And if they are both equal to 1, then they're sharing a side vertically. So we will go if row 1 at A is equal to 1 and row 2 at A is equal to 1, then total P minus equal 2. And that's it. Right? Not quite. we'll of course print out total P. However, there's one thing missing. Let's go back to this iPad. If two triangles are touching vertically, as we mentioned, since they are sharing a side, then we subtract by 2. However, what happens if this is how they are sharing a side? If so, they can both be wet. But are they really sharing a side here? Not quite, because if we were to say this is not wet, we would see that for the top triangle, we would get 1, 2, 3 sides that need to be covered. And for the bottom triangle, we would get a 4th side, a 5th side, and a 6th side that needs to be covered. So really, all the sides still need to be covered. So how do we know? Well, we know that the first triangle is pointing up. And that means that the index of the row we're checking at 0, this is true. At 1, this is not true. It doesn't matter if they're both wet. They're not touching. And on and on. No matter how far we go, at 2, it matters. At 3, it doesn't. At 4, it does. At 5, it doesn't. At 6, it does. At 7, it doesn't. What we can say is that if it's even, then it matters. Then you should check. But if it's an odd indice that we're checking, then it doesn't matter. And that's really, really easy to program. Instead of going A++, because we're going to be starting at index 0 and then going to index 1 and then index 2 and then index 3, we'll just go plus equals 2, which means we'll be adding by 2 every time. So we'll start at 0, and then we'll check index 2, and then index 4, index 6, and on until we meet the condition. And that is it. So we can just, for the sake of making sure we got it right, try it out. Let's take this input right here, the sample input. And I apologize for what you're about to see because, yeah, shoot. I don't know why PDFs get all messed up, but it's okay because we'll just make the spaces ourselves. 9, which is the correct answer. I'm going to try the second input too. By the way, the reason why I'm not checking on the official compiler or Daymosh is because it's not out yet. The contest was only a couple days ago, but you guys can check for yourself. This is correct though. This was the same solution I gave during the contest. Okay, expecting 11, and we're gonna get, come on now. Come on now. I clicked the wrong button. 11. Amazing. Okay. That should be all. I hope this helped once again. And like I said earlier, if you believe someone can be benefited by this, please tell them. With that said, women like freedom, because I believe that's really, really important right now. And that should be all. Thank you so much for watching this video. And if you guys want to see more solutions, I'll link them too. Thanks. Also, code is in the link if you guys want to go check it out. Bye.